there, I hope you're doing well. So in today's video, we're going to be talking about something that you must know as a developer or as a software engineer, and that is data structures. So I'll be covering the basic data structures that you ought to know, and I'll be talking about them, talking about their strengths and their weaknesses, and also talking about when you should use them. So stick around if you're someone that wants to know what you need to do when it comes to data structures, and also subscribe if you have not. So let's do this. So before we start, I need to mention that before getting into this video, you need to have an idea of big O analysis and running times, and also have a basic idea of what a data structure is. Otherwise, if you don't know about that, feel free to comment down below if you want me to do a more specific video on big O analysis and also talk about what data structures are. Data structure number one, we have arrays. And so an array is a linear data structure that basically consists of a fixed size collection of elements of the same data type. And the location of an array is referred to as an index, and basically an index corresponds to the position of an element in the array. So let's take an example of this array here. We have elements inside the containers, and then we have the indices. So when it comes to this array, the indices are what are actually going to help us get the elements that are located in this array. So for example, let's say we want to get the item number 6. How to get it is that we're going to get the item located at index 2. So one advantage of arrays is that they offer very fast lookup of data. To access data in an array, you use constant time, but they also have a disadvantage, and the disadvantage is that they have a fixed size, which makes it hard to add data once the size has been exceeded. So from that, you can tell when it is recommended for you to use an array, and that is basically when you need quick lookup of data and when you know the input size of data that you have. So on to data structure number 2. Data structure number 2, we have the linked list. So just like its name, a linked list is basically a chain of items that have been linked together. And when it comes to its actual definition, a linked list consists of nodes which basically contain data fields and a reference to the next node in the list. In contrary to arrays, linked lists do not have a fixed length requirement, or rather a fixed size requirement, and this makes them a better option for storing data that is of arbitrary length. So visually, a linked list looks like this. As you can see, we have pointers here which are basically connected to these items, and these here are the nodes. And so as you can see, 6 is linked to 4, to 9, to 2, and basically these here are the pointers, and that is why a linked list is referred to as a chain of items that are connected. So one advantage of linked list is that insertion and deletion happen in constant time, and this is actually quite fast. They however have a disadvantage, and that is that they have very slow lookup of data, which happens in linear time. So basically what this means is that if you're looking for an item in a linked list, you'll have to go through each node until you find the item. They also take up a lot of space and a lot of memory because of having to store the pointers. So when should you use a linked list? You should use a linked list whenever you do not need quick lookup of data and whenever you have data that is of arbitrary length. So onto data structure number 3. So data structure number 3, we have queues. So a queue, just like its name, has a fast in and fast out ordering system. So basically when you mention a queue, you think about the line that someone has to make at the counter, or a line that you have to make whenever you're getting into a bus or getting into a plane. So a queue follows this kind of ordering system. So let's have a visual representation of how queues work, and then we're going to look at when queues are actually recommended to be used. So when it comes to queues, like we have said, they are a fast in, fast out data structure. And basically what this means is that whenever something is put in fast, it is going to be the first item that will actually get out fast as well. So let us have an illustration here. Let's say we have this queue here, and we want to put items inside this queue. And let's say this is the data set that we have. And then we have 3, and then we have 2, and basically we want to put this inside this queue here. So what is going to happen is that we are going to be putting them in an order, and this, because this is the first one, it's going to come here 5, 4, 3 and then 2. So one thing that you need to know is that this operation that we have done here, basically pushing elements to this queue, is referred to as enqueuing. So basically whenever you push an item to a queue, you're basically doing enqueuing. So basically we're going to have to remove this first because it was the first one to get in, and this operation is going to be referred to as dequeue. Okay, so I hope that you have seen how queues work, and I hope you actually get to see why they are a fast in and fast out data structure. This is something that you have to remember whenever it comes to queues. Okay. One strength of queues is that just like the linked list, insertion and deletion happen in constant time. And one of the disadvantages is that just like the linked list again, they have very slow lookup of data. So when should you use queues? You should use queues whenever your data requires a specific type of ordering. So in this case, whenever your data needs an ordering of fast in, fast out, it is highly recommended that you use queues. So onto data structure number 4. Number 4, we have the stack. So a stack is an opposite of the queues in that they have a last in and fast out ordering system. So let's have a visual representation of stacks so that you can have a better idea of how stacks work. So let's say we want to arrange books into a stack and we want to order them in form of a stack. What I'm going to be doing is that I'm going to be adding books on top of each other, and as you can see, they're forming a stack of books. So basically how a stack works is that the last item that I put into this stack will be the first item to come out. So in this case, if I need to get this book here, how it's going to work out is that I'm going to have to take out this book first, because this was the last one. It's going to be the first one to come out, and then next this is going to be the next book that will come out, and then finally we get to this book. And that is why stacks are known as a LIFO data structure. And so let's have a look at this stack here, for example, and we have containers whereby we want to put in data in this stack. And so one thing that you need to know is that stacks have the push and pop operations. So whereby the pop operation will remove an item from the top. So the pop will remove an item from the top, and the push operation will add an item to the stack. So in this case, if we have this data set, so let's say we have 8, 5, 6, 7 and 8, and we want to add them to this stack here, we're going to push 8, we're going to push 5, we're going to push the 6, and then we'll push 7, and then we'll push 8. So if you want to remove the elements, we'll do that using a pop. So we'll be removing from the top. So we'll be removing the topmost, and then we'll go to 7, and then we'll go to 6, 5, etc. So basically that is how stacks work. And I hope you can see why they're actually referred to as a last in, fast out data structure. So one advantage of stacks is that just like the queues and the linked lists, insertion and deletion happen in constant time. And one of the disadvantages again is that just like the queues and the linked list, they have very slow lookup of data in that search happens in linear time. So when should you use stacks? So basically you should use stacks whenever your data requires a specific ordering system, and in this case whenever you need to have data that has a last in and fast out ordering system. So onto the next data structure. Data structure number 5, we have the hash table. And this is sometimes referred to as a dictionary. So in a hash table, data is stored in array format whereby each data value has its own unique index value. So hash tables use a technique known as hashing to generate an index whereby each item is to be inserted or is to be located from. One advantage of hash tables is that They support very fast lookup of data. They also support very fast insertion and deletion, all happen in constant time. They, however, have a disadvantage, and this is basically there is a possibility of collision of keys. So when should you use a hash table? You should use a hash table whenever you don't need data that is sorted, and you should also use it whenever you want to have something that does operations quickly. So because you see that a hash table does insertion, deletion and search very quickly. One more thing, so if you want to actually know how hash tables work and basically have an understanding of how to use a hash table, feel free to comment down below, and I'm going to make another video to talk more about hash tables, because I feel like this is something that a lot of people out there struggle to understand. So yeah, feel free to comment down below, and I will have another video talking about hash tables in specific. And to the next data structure. So data structure number 6, we have the tree data structure, and a tree data structure, just like its name, basically simulates a tree and simulates a hierarchy. So what this means is that a tree data structure has a root or a parent, and it has children who link to the root. So common examples of tree data structures are file directories and company organizations. We also have special examples of tree data structures, and these are the binary trees. We also have the binary search trees, and we also have the heaps. So in this video, I'm not going to be talking in depth about these special trees, but if you want me to talk about them, feel free to comment down below, and I will talk more about them and how they work in another video. And then one advantage of trees is that they support a very fast lookup of data, and they also have insertion and deletion that happens quite fast. However, this is not as fast as hash tables. One other advantage of trees is that they also save up on space, because you see these nodes can be reused. So when should you use a tree? You should use a tree data structure whenever you need to store data in a specific order, or whenever you actually need a data structure that has quick operations, let's say in insertion, deletion, and also when it comes to search. So we have covered 6 basic data structures, and I hope that you have learned something, but feel free to comment down below if you need a more in-depth video of each data structure and how they work, and also if you need to see how to write code for these data structures. So thank you so much, and I hope that I will see you on the next video, and do not forget to subscribe. Thank you.